Chapter 5. Chapter 5 is all about trig identities. You know, an identity is an equation that is always true. And we have used the identities already in our trig class. And so this is going to be some of which you already know. This will be easy. If you don't, this is another opportunity for you to learn it. We are going to, in this unit, use identities to evaluate trig expressions, simplify them, develop more identities, and to solve trig equations. And we're actually going to do the first three starting in this section. Solving trig equations will come later. And if you recognize this cartoon, this is the Hell's Angles poster that I have up in our classroom. And it always makes me smile. Okay, so we're going to use trig values, known trig values, to evaluate the other trig functions. And you can see here in this example that we were given that cosecant theta was 2 over 1, and that tangent theta was equal to square root of 3 over 3, and it asked to find all 6 trig functions. So what that means is that I'm looking for sine, theta, cosine theta. I've already been given tangent theta, but I like to write these in order. I want cosecant, which I've been given, and in fact I'm just going to go ahead and write those in that same color so I know that I already have them. Secant theta and cotangent theta. All right, and we remember that the reciprocal functions are across from each other, so cosecant and sine go together, so sine is just 1/2. And cotangent would be square, I have that wrong, hold on, square root of 3 over 3. Didn't write it properly. So if I flip it over, then this is going to be 3 over. If I rationalize that, I don't know if you realize it, but it would be this, square root of 3 square root of 3 over 3, right? Which looks like a more familiar value for tangent. All right, and then cosine, if the sine of theta is 1/2, I know that the cosine, this is off the unit circle, right? So what I'm looking for are all the angles of pi over 6. So cosine is going to be square root of 3 over 2, and secant is going to be that upside down, the reciprocal. And that would, of course, be 2 square root of 3 over 3, but you can leave it unrationalized. Now, of course, they throw you a curveball, and it's been a little while since we've looked at co-functions, but what I want you to notice is that this doesn't say the cosine of x, the denominator does. It says that the cosine of pi over 2 minus x, and if you're thinking in degrees, that's 90 minus x, so you're still talking about a right triangle. We'll talk about co-functions here in a minute, but if this is x, remember that this angle here is 90, or pi over 2 minus x. So what it's saying is if the cosine is 4 over 5, then what's 3 over 5? The cosine of this angle is 3 over 5, this one here. Well, that's the same thing as the sine of x. So what this is saying, the cosine of pi over 2 minus x is really just a fancy way of saying sine x. So this says sine x over cosine x, right, which is tangent x. And if you look at tangent x on the triangle is opposite over adjacent, or 3/4. So that's what they're asking for in this particular problem. So once again, if I want to do all 6, I already have sine, I already have cosine, and I already have tangent, right? Because I know the sine is 3/5, the cosine is 4/5, and so the tangent is going to be 3/4. So then cosecant is going to be 5 over 3, the secant is going to be 5 over 4, and the cotangent is going to be 4 over 3. Using all the identities that I already know. Here's a quick review of the co-functions, remembering that if they're written this way, the angle pi over 2 minus x is just the other acute angle in a right triangle. It's the other one. Not theta, but the other one. And remember, this third one right here is the right angle. And so we're talking about the acute angle. So remember that the cosine of the other angle is equal to the sine of x. The sine of the other angle is the cosine of x. The tangent of the other angle, so I'm looking here, tangent would be this, would be the cotangent of x. The cotangent of the other angle would be tangent. Secant would be cosecant. And cosecant would be secant. And you can see what those are. So anytime you see pi over 2 minus x, you think to yourself, wait a minute, that doesn't mean that function, it means the cofunction. And so you can actually simplify a cofunction anytime you see it to just a regular trig function. This is a review. You should know these already. The fundamental identities, the reciprocal identities. So for instance, the secant is going to be 1 over cosine theta. The cosecant is 1 over sine theta. The tangent is 1 over cotangent. And you can write those the opposite. So you could say that cosine, in other words, cosine is 1 over secant. You could say that sine was 1 over cosecant, right? And you could say that cotangent is just 1 over tangent, right? So you can have, just from these three, then you can derive these other three. The quotient, sine over cosine, sine theta over cosine theta. Cotangent's the opposite, the reciprocal, so cosine over sine. And then the Pythagorean identities. This is really super important that you remember the Pythagorean identities. The first one is that sine squared theta plus cosine squared theta is equal to, guess what? 1. All right? And then the other two are, they start off a little differently, but they also have 1 in them. So 1 plus tangent squared theta is equal to secant squared theta. And then the last one that isn't used as often is in the same form, but it's cotangent squared theta and cosecant squared theta. Okay, you should know these, but if you don't, write them down. It will help you remember them. Also, if you have some kind of mnemonic device or song or chant or something like that, it would make these easier to remember. But barring that, go over them a little bit every day. Maybe make a flashcard, something to help you remember these, because they are going to be vital in doing some of these identities. Simplifying identities is all about a puzzle, and if you don't know the rules and the pieces to the puzzle, it makes it ever so much more difficult. So learn them now if you don't already. Once again, these are the even and odd functions, and if you can remember these, it will make your life so much easier later on. Remember, we talked about making the angle the negative of the angle, and some of these functions are even, which means they're symmetric about the y-axis, and so the cosine of a negative angle is just equal to the cosine of x. So anytime I see the cosine of a negative angle, it's just going to equal cosine. I can rewrite it. Secant is the same way. They're both even. So the secant of x. And if it's odd, what it means is it's symmetric about the y, or about the origin. It's symmetric about the origin. Even is symmetric about the y-axis. It's got symmetry. Odd is symmetric about the origin. So it changes quadrants, and so this is actually going to be negative sine x. So everywhere I see a sign of negative angle, I can write the negative of sine x. Cosecant the same way, because these are all odd. Negative tangent x and negative cotangent x. And once again, take the time to remember these now, because later on when we need to use them in a complicated identity, it will be ever so much easier if you have these committed to memory. However you need to do that. Okay, now we're going to use the identities to simplify these expressions. We used them to evaluate earlier, now we're going to use them to simplify. So one of the things that we can do is take cotangent and secant, number 1, right here, and convert those to sines and cosines and see if anything cancels. So we're going to use quotient for this one, and we're going to use the reciprocal for the secant. So what that means is I'm going to write cotangent as the cosine x over the sine x. Remember, they're equal to each other, so I can replace. Secant is 1 over cosine x. Because this is multiply between, they're like a fraction, and so I can cancel the form of 1. Cosine over cosine is just 1. 1 over sine is what I have left, and 1 over sine is a reciprocal function for cosecant. So in other words, this expression is equal to the cosecant of x. I could replace it. So I've derived an entirely different identity just by simplifying the expression. Okay, I'm going to do the same thing for number 2. Now number 2, cosecant, the reciprocal of cosecant is 1 over sine. We've been using this over and over and over. It should be good. And then cosine x, there's nothing to change it to. I end up with cosine over sine, which is what? Right, cotangent. So this is cotangent x. So we have, once again, a new identity. Cosecant x times cosine x is really, could be written cotangent x. All right. This last one here uses a Pythagorean identity. The Pythagorean identity is sine squared theta, or x. Yeah, I've got theta on the brain. Happens a lot. Okay, so this plus cosine squared x equals what? Well, the only number in any of the identities is 1, really, except for the squareds. So I can make this identity look like the numerator if I just say sine squared x equals 1 minus cosine squared x. Then for this 1 minus cosine squared x, I can substitute a sine. So if you look up here in the numerator, I can substitute sine squared x over sine x. And remember that sine squared x is the same thing as sine x times sine x, all over sine x, and you see a form of 1, and so this equals just sine x. Once again, sine x could be written like this because the expression can be simplified to sine x. Okay, here are a couple more. I notice here that I've got a plus sign. I've got a plus sign right here. So I've got actually two terms, something plus something else. So I can simplify this expression on the right. Cosine is as simplified as it will go. So I have cosine x plus, and then I have sine x times sine x over cosine x, right? And so what I have here is, I'm going to write it like this, cosine x plus sine squared x over cosine x. Well, this looks like a fraction, and it is. It's just I have trig functions in the denominator. So you're going to find a common denominator, right? And the common denominator, since this is 1, is going to be cosine x. So I write cosine x here plus, this one already is cosine x, so I'm done with this fraction, right? But I had a cosine x up here. If I add that, cosine squared, if I reduce this fraction right here, I'm going to end up with what I started with. So it's correct. These are the same denominator, so I can rewrite it. I'm not changing, I'm not skipping any steps here. So I have cosine x, I have cosine squared x plus sine squared x. Does that sound familiar? It's a Pythagorean identity. So I'm going to substitute for the cosine squared plus sine squared. It doesn't matter that they are in a different order as long as there's a plus between them. So I have 1 over cosine x, and that is secant. So this whole thing up here is actually going to be secant x. I could write cosine x plus sine x tangent x. I'm not going to memorize that because, you know, I'm not going to use that, but I can derive it from using my other identities, and that's what I'm trying to do. Okay, number 5. What you'll find here is that problems can be done in more than one way. For instance, the one way I could do this is change everything to cosines and sines, right? I have cosine over sine, that's cotangent, divided by sine over cosine, right? To divide a fraction, you take the denominator and you flip it and multiply across. So this would actually be cosine x over sine x times cosine x over sine. You thought it was going to be 1, didn't you? But it flips over, and so I have cosine squared over sine squared, which is cosine squared, cotangent squared, x. Okay? Now, there is another way to do this problem, and I'm going to change colors and come up here. You could have realized that cotangent is 1 over tangent divided by tangent over 1, and flip that over, multiply. 1 over tangent squared is cotangent squared. And then some of you may have noticed that there's actually another way to do this that might be even shorter, and that would be that you would have cotangent, I'm going to do blue, hold on, cotangent x over 1 over cotangent x, which you flip that and multiply, and you get cotangent squared x. So how many different ways are there to simplify this expression? Well, I've come up with 3 right here, and so that's what you're going to find, is you may be like me and do it the long way and still get the correct answer, or you may do it a different way and begin to see other ways of doing these problems. And as long as you justify your answer, it will be correct. So here's an important thing. Your answer may look different than your neighbor's answer, and both of you may be completely correct. So keep in mind here, there's an opportunity for you to be clever. There's an opportunity here for you to see things in a different way. If you'll think of them as puzzles, as long as you know the pieces and the rules, you will do fine. But practice. Practice is very, very important. Here are 2 problems that I want you to work in your composition notebook. Please have these in your notes tomorrow after watching the video. I'm going to be looking at the quality of your notes. Some of you have this down pat. Others of you have gotten a little lax in copying down what you need. So be sure that you have worked these problems and shown all steps. See you in class.